Alright guys, so in my last video I discussed about the design principles of Kafka and the way it works, and also we talked about the fundamental aspects of it, and we also discussed about sync and async communication. So now in this video particularly we will try deploying the event driven architecture, and then we will discuss and we will try to deep dive inside the Kafka cluster and the Kafka Connect and other services as part of the Confluent data platform. Alright, so this is my Azure cloud and this is my Kubernetes cluster, and here I have a Confluent platform. So it's not a different resource, it's just logically separated. I have written these dot lines. Okay, then you have your database here. So although your Confluent platform will have a lot many applications, but we are considering writing only few of here. In my last video, if you have discussed about it, I have written the Zookeeper also. So we will write Zookeeper, and then we will write this Kafka nodes, and then we will write Kafka Connect. Okay, only 3 of it, and others you can see at my manifest file. I'll show you. So this is my Kafka. Okay, and then assume that this node will be my Zookeeper, and then this will be my your Kafka Connect. Okay, now there could be multiple number of it because you will have multiple nodes associated here. So I'll also have multiple replicas for Kafka Connect, and then I will also have, I'll write it here, I will also have multiple Zookeeper here. Alright, and then your invoice consumer right here. So this Kafka, this particularly Kafka, this part, right, this has your topic and everything inside. Now I let me draw a queue architecture here, right? Although that it's not a separate resource, remember it's a conceptual resource. I'm writing it here, right, just for a theory perspective. So I'll say queue here, because everything in Kubernetes is nothing but your pod, right? So I'll write queue here. Okay, now let's say this is your Azure subscription. I'll say Azure subscription. Okay, now yes, so the way it was, and this is a Postgres database, you already know about it. Now in this cluster assume you have a table is equal to invoice. Okay, so I want to create, the problem statement is I want to create events from the events of invoice. So let's say your application is being deployed for APAC region, Asia Pacific region, and you have multiple deployments, you have multiple retail outlets running for your brand, for your company. So and then the database you are using is Postgres, a kind of transactional database. Now there are many invoices that are being generated day in day out, so all that invoices are being stored under this Postgres database. Now I want to generate events out of it because I want to do something as part of the invoice processing. Alright, so the best way of doing is that there could be one thing, right? You write a listener or you write a job which will basically go to the database, try detecting all the new invoices written, and then start consuming all those things, etc. That is making the whole system complicated. The better way of doing it is I'll try to deploy a data pipeline, a kind of a data streaming pipeline, where whenever something gets written in the table invoice, an event will get generated, and this guy invoice consumer will keep on consuming those invoices, and it will do something. Let's say as part of the do something activity, it will kind of invoke the other listeners for that particular invoice. So you will have Kafka Connect here, right? So this Kafka Connect will watching this table invoice X. So whenever there is an incremental change to Kafka Connect, I will tell that you look for the field, the column ID is equal to invoice ID, right? And then whenever there is an incremental change, okay, whenever there is an incremental change, when I say incremental change, that means in Kafka Connect you could do something like incremental or timestamp based, right? So because understand from the Kafka Connect perspective, how Kafka Connect will know, okay, there is a new entry, this is a new entry, or this is the entry that has been updated again. So one way of doing is you use an incremental feature. You will tell your Kafka Connect. So okay, you keep on watching on column ID, invoice ID in the table invoice, right? And then there is an incremental change. Let's say you have a value 1 and then there is a value 2 that is being written in the database, and you have the invoice ID as 2. You pick this new one because you don't have this 2 in the topic. So that's how your Kafka Connect works. So Kafka Connect basically has source connector and the sync connector. So Kafka Connect is the application in the Confluent platform which has multiple connectors, using which you can connect your connector with a database, a data source basically, which will act as a source of data and convert it to the event and store it to the topic of Kafka. Alright, and then from the topic of Kafka, you could have a sync connector if you are implementing the change data capture. If you are not implementing CDC, you could directly consume that message to an application like invoice consumer. That's what we will do for implementing the CDC, which will basically create a replication between the Postgres database and a Cosmos Mongo. We will create another video series. But in this video series particularly, your Kafka Connect is I'll write, which also has your source connector. Okay, source connector for JDBC. Okay, understand in deep, guys. This is real engineering. Now this source connector, your Kafka Connect, will send it to this queue, which is nothing but this Kafka nodes. Alright, so when it will send it to the queue, I'll make it large, it will convert it into an event. So a single row of your database entry will become as it is to an event, data in the topic. Alright, so I will write event here, right? So let's say a new data X, event will become X. Okay, so you have an invoice ID 2, invoice ID let's say 5, which has a data with customer Suchet, right? Customer name Suchet. So what will happen? You have your database entry gets created, the row will get created 5 Suchet customer, etc. That as it is, that particular row, this Kafka connector will detect, okay, 5 has been written. I will copy that 5 and copy it to the Kafka topic. So this has your Kafka topic, and then from here, this guy will consume the messages. All right, so this is listening on a topic. Okay, now so this guy will get the invoice which has an ID 5 and also customer name is Suchet. That's how your event driven architecture is working. You see that there is a change has been made in. There is a change that has been made into your invoice table, which is in the Postgres database. From your Postgres database, using Kafka Connect, you are converting that row entry to your event, and from that event, your consumer application, which is basically nothing but a microservice, is reading your data, right? So as part of this architecture, we will have to deploy Kubernetes cluster that we already have provisioned here. If you go here, this is Kubernetes service which is already running. All right. So, and I have to deploy this Confluent platform, which is important. And then we already have this database, right? In the earlier video also, I've shown you this Azure Postgres database. If you go, I have provisioned this Azure Functions DB. Okay, guys, so this is my database. Already I have dbeaver and everything set up. Okay, so let's move on directly to the implementation. I'll go to event-driven architecture. I'll save it first. So to implement Confluent platform, Confluent already has this GitHub repository. If you go to Confluent, right, they already have, this organization already has a very beautiful GitHub repository. You could go Confluent Kubernetes example. They already have manifest file and everything. You don't have to create it from scratch. Even you can't, it will be a difficult one, right? So go to quick start deploy, go to Confluent platform. Okay, so this Confluent platform, there are manifest file already, right? And then if you go back, they have already told you a basic guide that you can use to implement your Kafka Connect. But remember, you will have to deploy some CRDs before implementing this Confluent platform. Okay, so I have already copied this to my repository. I have created one repository, GitHub repository. If I go to repository, I'll say Confluent Platform. Okay, so in my Confluent Platform, I already have all those things. All right, so I can quickly open it here. Yeah, okay. So you see, I already have this file here. Okay. So now, although there is a separate folder for Kafka Connect, I'll tell you why. And this is my Azure DevOps pipeline definition, right? And then this is my Confluent Platform, all the manifest file. These are nothing but the manifest file, Kubernetes manifest file. You see, it's trying deploying Zookeeper, right? And which image it is using? This is the image it is using. And then it's using, and it's data volume capacity, and then it's trying to deploy Kafka in which namespace, retail dev namespace. So all those customizations I already did all those customizations. So you see, Confluent Platform comes with many applications, schema registry, and then control center, KSQL database. However, you don't need everything, right? You only need your Zookeeper, Kafka Connect, and then control center you could use, but that's a premium one. That's a premium feature. You could use something like open source. We will be using an open source platform, and then you have to use schema registry. I think these are pretty much these are enough to basically deploy the Confluent Platform, right? And then this is our pipeline, right? So this is your Kafka Connect file. So this has a Docker. So your Kafka Connect, the Confluent Kafka file comes with a default implementation. Now I want a Kafka Connect to connect with the Postgres database. So my Postgres database, with Postgres database, it creates a JDBC connection. With MySQL it creates a JDBC connection. That is why what I'm doing is I'm trying to create a Kafka image, and I'm also running a command, Confluent Hub install. When you are creating this Docker image, install this Kafka Connect JDBC. Avro converters is kind of your JSON converter, data for using for conversion of data here and there. I'm also asking this Kafka Connect to install in Docker image the Mongo connector. Although I don't need this one as part of this video series, right? So I only need these two. All right, so that is how I'm creating a Kafka Connect, and that is why if you go to your Azure pipeline, you will see I'm using this Uchet Consulting Pool, which is my self-hosted agent. And then before deploying it to the Kubernetes, all the manifest file, what I'm doing is I'm asking my pipeline to run this Docker file first. So as part of this task, it will create a Docker image for a Kafka Connect along with the JDBC connector with it. And the tag of this particular image, I'm tagging it as 2. Now, this task particularly talks about the deployment of these all files. So I have this manifest file, Confluent Platform.yml. Okay, so in this YML, if you go, all these different services are basically written, right? So these services, for example, if you look at the Kafka, so this is mentioned. So the image it is referring to is Confluent Inc. from the Confluent Docker repository. But interesting part is, look at the Connect one. It's not referring Confluent Inc., right? Because we manually customizing a Kafka Connect image, and we are storing that Docker image to our custom Azure container registry. So from where we are trying to download this Docker image. All right. So this is about the Confluent Data Platform. So now if I want to deploy it, right, what I'll do is I'll connect with my terminal. Okay. So I already have a VM because my Kubernetes is a private cluster. So I cannot directly connect it with that private cluster unless I connect with the VPN gateway, the one I have created. So I preferably not use that because that's a costly resource. I already have a VM. This VM is already deployed on VNet, retail solution VNet. So from this VM I can directly access my Kubernetes cluster. So majorly I will run all the commands from this VM itself. So if you see, I already have this virtual machine here. This one, retail self-hosted agent machine. Okay. So let's go to my machine and I'll connect it with the, so I have this public key. Okay, so I'm connected. Okay. So you see, currently, all right, seems like there are these pods running. Let me see, Helm list. Okay. All right, guys. So to deploy this pipeline, the pipeline I was talking about, right? So basically, in my Kubernetes cluster, I already tried deploying this this Confluent platform. So in just to show you the demo, right, how to deploy it, I'm deleting all those things. Then we will deploy it again. So we will get an understanding, right? So if you see, let's go back to our architecture, how this is being deployed, the way this is being deployed, the same way, right? Assume that this is our Azure DevOps. So I'm not writing, because in my last video, I explained you this whole concept of Azure DevOps. If you go and check out my CI/CD video using Azure DevOps and Azure Kubernetes Service, this is what I explained. So I will not write all those things right here. What I'll do, I'll simply use the term Azure DevOps. Okay, and then I'll say Azure DevOps. Okay, so just understand that as using Azure DevOps, I'm deploy everything right here. Okay, now so from Azure DevOps to deploy this Confluent pipeline, I have to create a one pipeline that I have already created one. So if I go back to my organization and if I go to my project, I go to my pipeline, you see I have multiple pipelines, right? So if I go to say 007 Confluent 1, this is my pipeline I have set up for to deploy Confluent Platform into Kubernetes service. So if you click on edit, you will see the Azure definition file. Okay, so it's again referring to Azure definition file. This is same as this one. I'll put it down. So this is same as this one, right? Where I explained I'm first creating a Docker container image and then I'm deploying it, deploying all the Confluent services to my Azure container, from my Azure container registry, and then to Confluent Platform. So remember, Azure container registry is only being used to deploy this Kafka connect. That's the only a Docker image that we are taking from the Azure container registry. All right, and others will be consumed from the basic Confluent Inc. Docker Hub repository. Okay, so this is your Confluent. This is your file, Azure definition file, or the definition pipeline file. This is same right here. All right. So what I'll do, I'll go back, and then we discussed about this Azure Platform 1, and this invite service is something that we will create. Okay, after deployment. So what I'll do, I'll go back and check if all the services have been deleted or not. So we will wait for some time till the time all services will get deleted, and then we will again start a fresh deployment of Confluent Data Platform. All right, guys. So let's deploy this Confluent Platform to our Kubernetes service. All right. So our Kubernetes service, it's already running, right? Okay, it's running. Alright, so let me access this. So one way is I'm already connected to my Azure Kubernetes service from my local computer. The way I have connected is via this Azure VPN gateway. Obviously the client and the client to gateway, and then to virtual network to Kubernetes service. That's the traffic flows this way. So one way is I directly use this kubectl apply -f and then the Confluent platform.yml, but that's not the correct way, because the way we want to deploy in our Kubernetes service using Azure DevOps. All right. So I have only indicated Azure DevOps by just icon, because if you remember in the last video I already discussed this whole architecture of our Azure DevOps in depth, right? So if you go to my channel, search for CI/CD using Azure DevOps and Kubernetes service, you probably find this video. It's 1 hour around video where I have in depth explained the whole implementation and the walkthrough. So I will simply define all these things, indicate all these things by just single icon. All right. So if you see, right, I already have this pipeline. I already have this Azure pipeline file right here, where I'm creating a Docker image for Kafka Connect, and then I'm trying to deploy all those manifests into my Kubernetes service. All right, so manifests are inside Kubernetes platform or YML, and there's repository container registry because most of the registry are being make of the Docker images are being taken from the Confluent repository, but this one we are using specifically for Kafka Connect, because if you remember, if you see, right, we are building a Kafka Connect Docker image and sending it to our this repository retail solution. All right, so let's move on. So now what I'll do is, okay, I'll take you through the pipeline first. So I have already defined a pipeline. If you go inside in my project, I already have this pipeline defined. Okay, if you click on edit, you will see the same Azure pipelines that I just explained. And associate consulting pool is my self-hosted agent. Okay, so there is nothing fancy. So what I'll do, I will create a new namespace and then I will deploy everything into that namespace. So I'll go and replace. So I'll replace this with Kafka demo. I will replace all. Okay, so my retail dev namespace has been moved to Kafka demo. Now I'll create one namespace here. I might have already namespaces. Okay, so retail dev, it's terminating because I have deleted it just now. So I'll create one namespace Kafka demo. Okay, so so you see, where is that? Kafka demo namespace has been created. All right, so let's deploy it. To deploy this, we have to make a change in here as well. So I'll go to my Git and then I'll pull first. I'm not sure last time when did I pull the changes, if there are any. Okay, now I'll make the change. I'll replace, actually better ways to replace from here. Okay, I'll replace from Kafka demo. Alright, so this also I will save. Here we have not defined any, so I will go and commit updating namespace to Kafka demo, and then I'll simply commit and 1 second. Okay, now I'll commit and push the changes. Okay, so we have pushed the changes, and then this URLs, if you see, these are the URLs which will get created once you deploy these to the Kubernetes namespace. Okay, so I'll go to my GitHub, and then in the Confluent Platform, you will see that this changes has been merged to the main branch. I'll go to my pipeline and we'll see that this pipeline has to begin, but so this pipeline is on hold, not running, right? Okay, so do you know why this pipeline is not running? Because my agent see, agent request is not running because all potentially are running other requests. So it's in queue. So because of the fact my agent is not running, my self-hosted agent is not running, and this pipeline is not running, it's still in the queue. So I have to put on my agent, right? So what I'll do, I'm inside my VPN, I will go to self-hosted agent. If you want to have a look at self-hosted agent video, you can check out my another video. So you will see why I'm running all these commands and everything. Alright, I will hit enter and my agent will get a start. Okay, scanning for tool capable, connecting to server, listening for jobs. Okay, now this job will start. See, the job has been started because my agent is, go to agent pools. See, it's running a job, right? It's online and it's running a job. Okay, I'll go to my pipeline again. Okay, so this pipeline has failed. Now what has failed? Permission denied while connecting to Docker socket. I see. Okay, seems like it doesn't have the access to my Docker. So from my agent, I have to, let me open all permissions for run docker.sock. Okay, chmod 777 where run docker.sock. Okay, this operation not permit. I'll have to use sudo. Alright, so now this issue will go away. Now I'll run my agent again. Oh, sorry. I'll run my agent again. Okay, so my agent is up now. I will rerun this pipeline. I'll go to my build and I will rerun it manually. Okay, so the job has been started again. So it has created a Docker image for Kafka Connect. Alright, and then meanwhile it deploys everything. I'll switch to my different namespace, which is the new one that I have created, which is Kafka demo, right? So I'll say current and then which is Kafka demo. So you guys don't have to use the commands, maybe because you can use lens as well. Many people in organization, they use lens. So see, these all pods have been deployed, seems like, right, as part of this Docker command. So this kubernetes, which command this one is? This is this command. Go back to your pipeline. Alright, this is the command. I'll close this. This is the command because we are saying deploy everything what comes under as part of Confluent Platform YML. Okay, and this is the Docker creation that we have created. So I'll go back and then I'll go back here. I'll say here. Okay, and then here let me switch. I don't wanted to use that terminal. It was kind of small in size, so I'll switch to Kafka demo here. Okay, I'll see if parts Kafka demo, nothing in the Kafka demo, right? Alright guys, let's check because our deployment was done using pipeline. Let's check if we have any resource. Yeah, I have, seems like there is nothing gets created, although Okay, let me see. Okay, get kubectl get all. Okay, it is taking some time. I'll go back and check the Confluent documentation. Okay, I deploy namespace. Okay, this. All right. I think we have to add some Confluent platform configurations as part of our Kubernetes changes. Yeah, that is why only see this name has been created. There is no replica and ready and status exist. So what I'll do, I'll quickly. I think this repo has been added already. So 1 second. I'll copy this and I will add it here, and I'll say namespace is equal to Kafka demo. Okay, it's installing it now. Confluent operator. Okay, so all the Confluent custom resources definitions are done. Yeah, because if you go back and check the Visual Studio file, here you will see that zookeeper, it's of kind zookeeper. So Kubernetes default type resource type of Kubernetes and come with kind as zookeeper and Kafka. So these all definitions are coming from CRDs. Okay, so if I go and do kubectl get CRDs, so I might, yeah, see there are many CRDs I will get. So I think now I'll go to kubectl get pods. Okay, so now it's getting up the Confluent platform. All right, and if I do helm list, I'll see Confluent operator because we deployed Confluent operator as a helm chart. Okay, so I'll wait for some time. I'll wait for this to get up properly, and then we will continue. Alright guys, so let's check now if all the services. Alright guys, so let's check now if all the services have been deployed. Alright, so seems like all the services have been deployed. Right, so now I want to access the Confluent control center because that's the UI, right, over the whole Confluent platform. So what I'll do, I'll port forward SVC. 1 second, I don't know the port. So what I'll do is I'll say kubectl get SVC. I'll take the port. So control center is running at port number 9021. I'll run kubectl port forward. I'll see control center, yeah, center, and then I'll see 9021. Okay, okay, so my port has been started. I'll go and check 9021. Sorry, what is wrong? Okay, it's opening but kind of slow. I'll say again. Okay, still running. Okay, so this is my cluster. So this part has been deployed. If you see this, we already had the Kubernetes, we just deployed this part. Okay, so our Kafka cluster is, the whole Kafka cluster is up the Confluent platform. We have the zookeeper nodes. If you go and check for nodes, right, we have zookeeper nodes, then we have schema registry nodes, we also have the Kafka REST proxy, We also have the different nodes of Kafka and the control center and the Kafka connect. So connect 0 is the connect, Kafka connect, and then we have the Confluent operator, which basically downloaded all the CRDs and everything. All right, so now this part is over, right? If you see this, okay, let me go back to control center. Okay, we have these Kafka topics. So these are by default Kafka topics, and then I'll go to connect. This is my Kafka connect. Okay, so we have this source containers. Now I will have to connect my source container to my database, because my database is already running. If you see, I initially in the beginning of this session I explain you this Postgres flexible setup. Now what I want is to connect this Confluent platform with this database, specifically this Kafka source connector with the invoice database. So how can we connect that? So in order to connect this, I will have to go to my GDP source connector. So there is sync connector and source connector I explained you. So this is source connector. For source, the data you are taking from the source data source, and then sync the data, the source data you will have to sync with the end database. But here in this particular scenario, we will be talking about source database. So what I'll do is I will go to my Confluent, right? This is my source connector configuration. Okay, so what I'll do, I'll go to my Confluent property. Okay, and then from here I will simply, okay, so this is my the database JDBC source properties. I will have to copy this data from here to here. Okay, so what I'll do now is I'll start copying all the data. If you go to topic creation, offset topic, JDBC URL. So first of all, I'll connect to my JDBC URL, which is this. All right. And then I'll copy this. This is admin user 12. This is, although you might have seen my password, but I'll probably change it later, because I don't want to make my password public. Connection attempts is I don't need this, and schema pattern I don't need all these values, and then probably incremental column ID, right? It is invoice ID. Timestamp, I'm not using timestamp. So the way it works is I'm telling Kafka Connect to look at the invoice ID, right? If you see here, I'm asking my Kafka Connect to look at the invoice ID and see if there is any incremental change. You get the data, whatever the new data is, right? And if you use this change, this timestamp column, then what will happen, instead of incremental ID change, your Kafka Connect will look at the timestamp. So let's say if there is a X timestamp, and then after some time it's a X plus 1 timestamp. So from X1, all changes, whatever changes that have done after that X time, it will pick up all those records and send it to your Kafka topic. All right, so I will simply put in all these values. All right, guys. So okay, and then I almost entered all the values. Query we don't need, it will automatically do the query. Table, I believe we have not mentioned the table. Where is my, okay, table dot whitelist. Yeah, I'll copy this table and to the whitelist. This is the table that we want, right? And then where is the topic creation? Where is topic creation? Offset topic, it will automatically create. Then where is my topic name? Topic prefix. Exactly one support, we don't need that, right? Topic creation, I believe it will automatically create the topic. And then transform, That's okay. Key converter class, key converter schema registry URL. Let me see, where is the schema additional property? Change to my Confluent, right? And then I'll go to connect. So I tried connecting with the connector. So if you can see, it's failing, right? So this is the configuration we use. In the configuration we already discussed some time back, right? So this is my database URL, my cloud database. This is my username. This is my database password. And then the mode I've used, I've used incrementing, right? So, and then this is my poll interval, and then this is my max rows per batch. All right, and then this is my topic. So when it will create a topic, it will start with this name, and this is delay interval, and this is my schema registry. So when it fetches the data and everything, it creates a schema of JSON. For example, for a row, there could be a number of attributes. So that attribute will become the JSON attributes, right? So that's the schema. It will save and store schema registry. So, but it's not connected, right? So I'll see why. I'll go to get pods. Oh, sorry. And then I look at the logs for connect. All right, so my DBC connection timeout. Connect timeout, right? PSQL exception connection timeout. Okay, this is timeout. All right, so seems like our database is not up. If I see, okay, see, my database is not up. So what I'll do, I'll start this database. So we were connecting to a database which is in this, not in the running state. So I'll start it. We will wait for some time. Alright guys, so my database is up now, right? It seems to be in up state. Okay, so now I'll go back and see if the connection has been made. I'll go back to my JDBC source connector. I'll refresh it. Connect. Okay, still seems to be an issue. Okay, now control center. Okay, it went timeout. Let's wait for some time. Alright guys, so our connect, we made a connection with JDBC. So there was an issue with the database because database was down, it was not started. So this connect was causing some issues, right? So I'll open this. So my pods, okay. So user record invoice ID. So this is an issue now. Okay, so this has failed. However, this is started. So I'll click here. So from two of them, one is failed and one has been started successfully. However, I will delete this one because I don't think I need that one. I'll go back. So you see, this is Kafka Connect logs. I see there are many issues because user record.invoice ID not exist. Okay, I'll say this is incremental. Where is table? This is my table, and then from my database, table whitelisted. What is the table name I have here? Retail DB invoice. Okay, I'll go back. I'll use this. I'll do next, and then I'll say launch. I will also download this file for my future use. Alright, so in some time this connector should get launched, right? And once it gets launched successfully, it will start copying all the rows to my topic as events, right? So I'll go back. Something is wrong. Okay, I'll go back to connector. This is running, right? And then this is incrementing table whitelist. I'll go back to my another connector. Table whitelist invoice. I'll go back and what are we using here? Table whitelist. I'll say retail DB invoice, right? So I'll copy, and then I'll say click next. I'll say launch. Okay, so connector has been updated now successfully after a lot of effort. It has been success now. So it's running, and it seems to be in good state. I will delete this one. I don't need this one, right? So I'll copy the name and delete this one. So we have set up everything. It's just our one microservice is pending, and we have completed this. We have set up the Kafka. The activity we are doing is setting up a connector between this Kafka connect source connector to the table invoice. So whenever there is a change made in the invoice table, there is a new invoice ID gets created. That data will be copied to our topic invoice. All right, so I'll go back to control center. It's still deleting. I'll wait for some time.